All right, so the first question asks, carbon tetrachloride can be synthesized according to the reaction above. A chemist runs the reaction at a constant temperature of 120 degrees Celsius in a rigid 25-liter container. Chlorine gas is initially present in the container at a pressure of 0.4 atm. How many moles of CO2 are in the container? So first, as I've written, you would use the equation PV equals nRT because that equation uses all the information that we were given. We know that there are 0.4 atm of CO2 already present. And we also know that there are 25 liters in the container. And we also know that the gas constant is 0.0206 atmospheres per mole times temperature. And we finally know that the temperature is equal to 393 Kelvin. Because 120 degrees Celsius plus 273 equals that amount. Now all you have to do is plug all these pieces of information into the formula and then solve for N, which is the number of moles of CO2. So after you calculate that, you should get a number of 0.31 moles of CO2. Now the second part of the question asks, how many grams of carbon disulfide, or CS2, are needed to react completely with the CO2? So we need to use the value that we just got, 0.31 moles of CO2, convert that to grams of CS2. So all we need to do is use dimensional analysis. So we write 0.31 moles of CO2. And then we know that there are 3 moles of CO2 for every 1 mole of CS2. And we know that because of the reaction that they give us in the free response question. We also know that 1 mole of CS2 is equal to 76.13 grams of CS2. And we can simply calculate that using a periodic table and finding the molar mass. Now, once you finish that calculation, you should get 7.9 grams of CS2. All right, so question 1b, part 1 is at 30 degrees Celsius, the reaction is thermodynamically favorable, but no reaction is observed to occur. However, at 120 degrees Celsius, the reaction occurs at an observable rate. Explain how the higher temperature affects the collisions between the reactant molecules so that the reaction occurs at an observable rate at 120 degrees Celsius. So as we can see, a higher rate of collisions equals that it's more likely for reaction to happen because the molecules are hitting each other a higher amount of times. So if there's more temperature, that equals more collisions because the faster the molecules move, the more they hit each other. So because more temperature equals that means more temperature also equals that the reaction is more likely to occur because a higher temperature makes molecules move faster, hit each other more, meaning that the reaction is more likely to occur. So question 1b2 is just asking to draw a graph, and the one that they give us is the one that I drew first. It has more energy for activation because it has more energy of collisions because it is at 120 degrees Celsius. But the one that I drew second is the one that the question is asking us to draw. That one does not have the amount of activation energy required for the reaction to occur. That's because it is at 30 degrees Celsius, and the molecules aren't moving fast enough, and they're not hitting each other fast enough for the reaction to occur. And then question 1C says that S2CO2 is the product of a reaction. And they basically ask us to draw a Lewis electron dot diagram for the S2CO2 molecule. For the S2CO2 diagram, we know that all of them will form exactly one bond. That's because Cl needs to gain only one valence electron, while S needs to gain 2 valence electrons. So Cl needs to form one bond with S, and S needs to form 2 bonds, one with Cl and one with S. That should fill all the valence electrons requirements. After adding the bonds, all that is left is adding the lone pairs. Cl has 3 pairs, while S only has 2 pairs. Now question 1C2 is asking what angle is between Cl, S, and S. So because of the lone pairs on S, it is slightly pushing the Cl away, but not too drastically. So it doesn't form a 90-degree angle. We know that it is obtuse, but only slightly. So that means because of our knowledge of shapes, we can guess that the angle is anywhere between 104 degrees and 110 degrees. And to be safe, we can just put the middle, which is 107 degrees. So question 1D gives us a little context. It says that CCl4 can also be produced by reacting CHCl3 with CO2 at 400 degrees Celsius. At the completion of the reaction, a chemist successfully separates the CCl4 from the HCl by cooling the mixture to 70 degrees Celsius. At that temperature, CCl4 condenses and HCl remains in the gaseous state. So the first part of the question says, identify all types of intermolecular forces present in HCl. So because the molecule is polar, we know that it has dipole forces, because dipoles form at both ends of the molecule. We also know that it has London dispersion forces because all molecules have that basic intermolecular force. Question 2 asks, what can be inferred about the relative strengths of the intermolecular forces in CCl4 and HCl? So we know that CCl4 condenses and HCl does not condense. That must mean that CCl4 has weaker intermolecular forces because the bonds are broken more easily to transition into a different state. We also know that CCl4 only forms London dispersion forces, so it's already weaker than HCl, which has stronger pairs. So because CCl4 has weaker intermolecular forces, their bonds are broken more easily, and that is why only the CCl4 molecules condense while the HCl molecules do not. That is the end of the question, and thank you.